BC student at National Institute of Technology, Karnataka, Suratkal. Well, my hobbies include taking naps for about 4 to 6 hours straight, and of course, I love traveling to different places in and around the college. One of the achievements that I'm low-key proud of is that when I was around 10 months old, I won first prize in healthy baby competition, which is held at my native. Okay, so that's about it. Let's get into the topic that is introduction to KiCAD. What's KiCAD? KiCAD is a computer-aided designing software used for designing PCBs. It's free and it's open source, supported by a lot of organizations all around the world, such as Raspberry Pi Foundation, Arduino, DGK Electronics, etc. Although there are a lot of other softwares such as DipTrace Eagle available in the market, we'll go with KiCAD as it's more flexible and easy to learn. For any, for a person who is new to the designing a PCB thing, I think KiCAD is a really good starting point. Well, I have also mentioned about an article in my reference slide on 10 reasons why KiCAD is better than the others. Please do check it out. But after knowing a little about KiCAD, let's now quickly see what's a PCB and how have they evolved over time. Well, before we could actually design PCB, there was something called as wire wrapping technique, which was being used. Basically, we take the components and put it on the insulating board, and then below the board, we wire it. Well, this wiring can be either done manually or it can be done with the help of machines. This technique came in 1900 something, and then in 1960s and 70s, it became really popular in large scale manufacturing companies. After that, a decade fast forward, we have something called a surface mount technology coming into the picture. Well, Raspberry Pi uses this technology. It basically takes the electrical component and then mounts on its surface. Well, the leads do not really cross the other side of the boards. And then came through-hole technology. Here we take the components and then we put in the drill holes that have been done on the PCBs. Lot of hundreds of boards can be manufactured using surface mount technology, but the only thing is we have to solder it using our hand. Well, PCB play a vital role in modern day as technology have become very essential in our everyday life. From being used in CT scanners or the X-ray screens to being used in our own smartphones, they have seen their wide applications. Even the automotive industries use PCBs such as the satellite navigation systems or our own radio system which has been used in the cars. They have all have PCBs playing their role in it. Well, these are not the standard PCBs that we prepare. These are something called as flexible PCBs that play the role. You can also see there's something called single-sided, double-sided, and multi-layered PCB. So how do you do it? It's basically, if you take a cross-section of a PCB, you have something called a substrate, which is an insulating material. Well, this forms the body of the PCB. If you put a layer of copper on one side, it forms single-layered PCB. If you put copper on both the sides, it forms double-layered PCB. Well, you can make the connection by putting copper in between both the sides to make a connection for both the layers. To form multi-layered PCB, what you do is you take the substrate and put above and below the copper, and it just increases the vertical length, and that's how you can form the multi-layered PCB. Now, after getting to know about PCB, its applications, how have they evolved over time, let's quickly go to the KiCAD software and try to learn how we can design one. Well, the first step is circuit design. This can be any basic circuit taken from the internet, or you can design one on your own. Or you can take it from a textbook as well. Once you have your circuit design with you, the next step is creating symbols. Well, I'll come to that part later. Let's go to the schematic capture. Okay, so schematic capture is also a very important step in KiCAD. So what you do is you have to tell KiCAD how your components are connected. So you can do it in eSchema. It's a tool of KiCAD. It's an inbuilt tool, so you need not worry about it. So when you open the eSchema and import all the components and then wire it through, you get something like this. I have given an arrow mark that says a new symbol. So sometimes you may not really find your component, in KiCAD. So that time you have to go design your own symbol. That you can do in library editor or something called a symbol editor. So I have designed the 7555 IC. It's very simple. It's very simple to design. Now you can do the connections, and you can use something called as power flags. These are basically the VCC and ground. You need not really connect all the sit and do all the VCC connection. Rather, you can just put the power flag. It will connect it later on. The next step is something called as footprint, creating footprints. Well, once you created a new, like you have most of the footprints are already available in KiCAD. It's an inbuilt thing. But once you create a new symbol, you may not really find the corresponding footprint. That time you're supposed to go and create one. So I created the footprint of 7555 IC. It's there on the right side. I'm sorry, it's on the left side. Now, the next step is nothing but generating the netlist. Well, what's netlist? It's a simple file which tells us how a schematic and footprints are connected. So once you have the netlist, include it in your PCB layout. It may tell you that there are few errors. Just clear the errors, go back to schematic and footprints and clear the errors, and then get back. After the netlist is generated, you'll get something as something like the picture below the netlist. It looks like a rat's nest, but it looks very clumsy in the start. But what you can do is you can take the components and place it wide apart, and then make the overlappings less, and then get it back in a rectangular compact shape. After that, next step is board layout. Here we connect the different pins by drawing the trace across it. It's a very important step, and it would be good if you thoroughly understand how to do this step before actually moving ahead. So once the board layout is done, once you connect all the the corresponding pins with drawing particular traces, you're done. You're done with the PCB designing. Well, what's next? The next step is what's next? The next step is generating Gerber's file. Well, this is a universally accepted file which you can send across to the manufacturers, and they'll unzip it and they can access your PCB board, whatever you design, and order one. You can do it at Oshpark or Lion Electronics or whatever manufacturer you're good with. Do place an online order and wait for your board now. Next step is, by the time your board comes, you can do the bill of materials and then order the other components which are not at your place. And then once the board comes, you can solder the components on the PCB. Well, that's about designing from scratch, going through the schematic, designing your own symbols, designing the footprint of that symbol, and then generating the netlist, and then coming to the board layout. Well, these are some of the references which I thought are useful for you guys. To start with, the first reference talks about how do you download the KiCAD. It's a link to that. The second one is the article I mentioned in the start, the 10 reasons why KiCAD is better than the others. And the third one is getting started with KiCAD by Sean Hammond. He is an amazing guy from DGK Electronics. He has his own YouTube series on the KiCAD, getting started with KiCAD. I think that will be pretty useful for someone who wants to start this KiCAD. I hope this is informative.
Thanks for watching. Subscribe and click on the bell button as to not miss out any content. Contact us here.